Google's self-driving cars are becoming an increasingly common sight on the roads around its Silicon Valley headquarters. And while the cars, with their distinctive rooftop sensors, are getting a lot of attention, they're just one of many research projects aimed at a future of more efficient and stress-free driving. Earlier this year, Toyota unveiled its autonomous safety research vehicle, a prototype Lexus that can drive itself. And in 2012, Nissan showed off a car that can park itself. For drivers, the dream of autonomous cars still focuses on unattended driving. But for automakers, that's just one of the potential benefits.
On a normally operating highway, cars take up a tiny fraction of the space. Mostly it's all, air between you and the car in front of you, to the sides of you, and so forth. Self-driving cars can actually chain together and use the highways far more efficiently.
In Spain, Volvo is already testing road chains. The vehicle in front is being driven normally, and computers keep the four vehicles behind it in place.
Request for joining.
Platform request accepted.
The closer driving makes more efficient use of road space and reduces drag, so fuel efficiency is increased. And there's also the chance to catch up on your favorite magazine.
Obviously, we spend a lot of time frustrated behind the wheel. The first thing a self-driving car can do is that you at least can be productive doing something else during that time.
But it's still some years off. The most aggressive goal of Google's Brin is 2018, and others say it's further away. The technology traces its roots to the 2004 DARPA Grand Challenge, a 240-kilometer autonomous vehicle race through the Mojave Desert. The winner only got 12 kilometers, but it did kickstart development. A year later, one team had dispensed with video images for a laser sensor. It proved so much better that by the third race in 2007, it was used in 5 of the top 6 finishes. It was developed by David Hall, the founder of speaker and headphone maker Velodyne Acoustics, which today makes it commercially and supplies it to Google. The LiDAR sensor can see all around a car and make out other vehicles, street signs, road markings, buildings, and also pedestrians.
It's important when you have a car that drives itself to get as much information as possible in a short amount of time, to be able to make decisions if the car has to stop or get out of the way, or if somebody else crashes into the car. And that's why there's 64 lasers that are spinning around and 64 sensors that's sending out a pulse. The pulse gets reflected from one object and comes back. And from that we can measure the distance, and from the intensity of the pulse we can measure the reflectivity of the pulse.
Autonomous cars use data from LiDAR and other sensors to match the car's position to an accurate 3D map that's already loaded into the computer. So the road needs to have been mapped for the entire system to work. That's why Google makes humans take over when driving through construction zones. And someone still needs to be behind the wheel, just in case something goes wrong.
Safety is a huge challenge for us. That's one of the most difficult things that we undertake from a technological point of view. And we spend night and day fretting about all sorts of rare possibilities. And I'm optimistic that we're going to be able to solve this issue. I expect that self-driving cars are going to be far safer than human-driven cars.
At Stanford University, researchers also have an eye on safety. Shelley is a converted Audi TTS. It has a LiDAR sensor in the front grille and GPS sensors on the roof, and a map of California's Thunderhill Raceway in its memory. The result? A car that can tear around the track at speeds that start to rival those of professional drivers.
So safety is our primary goal, and how we actually research that is on a racetrack. If we can teach a car to race on a racetrack at the limits continually, then that technology could someday be used in production systems on the road when a car runs into an accident situation.
And that's where this research might pay off first. Small parts of the technology are more likely to make it into production cars than autonomous vehicles to come out completely finished. For example, some cars are already fitted with radar sensors that will automatically stop if they sense a potential collision or if a car drifts out of its lane. It might not be the dream, but it will make our roads safer. In Silicon Valley, Martin Williams, IDG News Service.